All right, make sure you are on page 70 of your notebook. You need to complete this warm-up. You are going to draw and then obviously work out these problems. At this time, pause the video so you have a chance to complete your warm-up and then replay it when you are ready to go. Okay, now that everyone's had a chance to do these two problems, this is from yesterday. So remember that opposite angles in a quadrilateral that's inscribed in a circle are supplementary. So you should have 18x minus 4 plus 28x equals 180. Combine like terms, so 18 and 28 gives you 46x minus 4 equals 180. You're going to add 4 to both sides and divide by 46. You end up with x equals 4. The question, however, asks you for YRW. So YRW is this angle here. So angle YRW is 28 times 4, which gives you 112 degrees. All right, on number 2, we can't just set opposite angles equal to 180 because we don't know what this angle is. But it's very similar to an inscribed angle. If I extend these lines out, I can see that angle VED creates this arc, that entire arc. So remember, if we're going from an inscribed angle to an intercepted arc, we multiply by 2. So 78 times 2 is 156x. At this point, you should notice that you have every single piece of that circle, so we're going to add them all up and set it equal to 360. So 110 plus 156x plus 93x plus 1 equals 360. Combine like terms. So 249x plus 111 equals 360. And when we subtract 111 from 360, we get 249. So 249x equals 249, which means x equals 1. We want to find angle VED, which is this angle down here. So the measure of angle VED is going to be 78 times 1, or just 78. This is the work that I expect to see on your papers. This is the work that I will be checking when you take a test. If there's an equation that needs to be set up, you need to set up and solve it. Okay. All right, everyone should have a yellow sheet of paper in front of them. It's the notes for today's lesson. Make sure you have the date. And you are on page 71, so you will tape or glue this into page 71 after we're done. Okay, so we're going to talk about tangents and circumscribed angles. So let's start off by drawing a picture on the side that we can label, and that'll help us fill in some information. So we have our circle, and we know what a central angle is. We know that the central angle has a vertex that's in the center. Okay, so this here is my central angle. Okay, that's information we already know. So I'm going to call those points A and then C for center and B. Now, number 1 over here says a line in the same plane as a circle that intersects the circle in exactly one point is called a tangent. So here is what a tangent looks like. So from, like, say, point A, the tangent line is going to come out like this. It only intersects the circle at point A. Now I can have another tangent line, for instance, at B, and that might come out and look something like this. So both of those lines are known as tangents. Okay, it's our tangent line in both cases. Now, number 2 says if both segments are tangent to a circle from the same external point, so here these two tangent lines create the same external point, then the segments are congruent. So if two tangent lines come together in an external point, then those tangent lines are going to be congruent. Now, if a line is tangent to a circle, so remember here are our tangent lines, then it is perpendicular to the radius drawn to the point of tangency. So remember, this is a radius. It goes from the center of a circle to any point. Here is my tangent line. It intersects the circle at one point. These pieces here are perpendicular, so they create a 90-degree angle. And then lastly, number 4, a circumscribed angle of a circle and its associated central angle are, now I'll fill that blank in a second, so we need to know what a circumscribed angle is. We already know what a central angle is, so hopefully you see only one other angle at this point. This angle here is your circumscribed angle. Okay, that is your circumscribed angle. So the circumscribed angle and the associated central angle are supplementary. Again, meaning they equal 180 degrees. Okay, real quick, we need to fix our directions. So refer to the figure for problems 5 through 7. AB is tangent. So AB is tangent to circle C at point B, and AD is tangent to circle C at point D. Change that B to a D. Answer the questions to determine the measure of angle BCD. The first one is done for you. Okay, so let's look why these two are supplementary. So angle BAD and BCD, so the circumscribed angle and the central angle, by definition, are supplementary. Okay. But we want to write an equation to solve for x. So if these two are supplementary, our equation would be x plus 60 equals 180. Okay, the central angle and the circumscribed angle are supplementary, so we're going to set them equal to 180 degrees. We're going to solve the equation for BCD, which is the central angle, which is the equation we have above. We would subtract 60 from both sides, and our final answer would be 120. So the central angle is 120 degrees. We're going to refer to the figure here for the next few problems. Sorry, I had to pause the video for a second, so I'm not quite sure where I was, but let me go back. So we're going to use this figure here to answer the following questions. Again, IG and HG are both tangent to circle J. So how are GH and GI related? These two are going to be congruent because they are both tangent to circle J. We want to write an equation to solve for x. So if both angles are congruent, then both segments are congruent, we can set them equal to each other. So 2x equals x plus 12. In order to solve for x, I would subtract x from both sides, which means x equals 12. And then number 11, solve for GH. If I plug 12 back into GH, you end up with 24. Now, if we plug 12 into IG, we should also get 24, remember, because those segments are congruent. All right, let's flip on over to the back side. We're going to use the figure to answer some of these questions. we do need to fix this again. Let's see, AD is tangent to circle C at point D. Determine the angle measures. All right, so let's start with angle ABC. Angle ABC. So it's this angle here. Here's my radius. Here's a tangent line. If a line is tangent to the circle at the radius, what do we know about that angle? Hopefully you're saying that it is 90 degrees, that they're perpendicular. So that angle is 90 degrees. Let me try to make that a box now. Okay, that angle is 90 degrees. We know on the other side that this angle is also 90 degrees. Is that an option? No. Okay, so we'll leave that there. All right, number 2, find the measure of angle DCB. DCB is my central angle. Okay, remember the central angle and the circumscribed angle are supplementary. So I'm going to call my central angle X, and then I have my circumscribed angle. If I solve, I get X equals 140. Number 3, the measure of angle BDA. BDA. So B to D to A is just this piece here. So we know that whole thing is 90, but I want to know what just that piece is. Now, there are some things you know, and you may not realize that you know them, but you do. So let's kind of recap a little bit of information. We know that these lines are tangent so that they're congruent. Okay. There is a shape that you should now see in this figure. You should see a triangle right here. I'm going to redraw it up here just so we can look at it. So I just took this triangle and redrew it. Those pieces are congruent. This angle is 40. This is A, this is D, this is B, and this is the angle right here that we're looking for in our picture. Does anyone know what kind of triangle that is? Hopefully you're saying isosceles. An isosceles triangle has 2 congruent sides. And there's something else about an isosceles triangle that you learned in IM1 that you may or may not remember. But an isosceles triangle has base angles that are congruent. So if these 2 sides are equal, these 2 angles are also going to be equal. Which means whatever angle D is, angle B is also the same thing. So I could call both of those X theoretically because they're going to be the same. Now, I have a triangle, and all the angles in a triangle add to 360 degrees. So 40 plus X equals, oops, not 360, excuse me, 180 degrees. So 40 plus X equals 180. 2X plus 40 equals 180. If I subtract 40 from both sides, I get 140, and then divide by 2. That piece of the circle, or that angle, excuse me, is 70 degrees. Okay, we're going to be able to practice again down on some of these other ones. Measure of angle CDB. CDB happens to be this other piece that's attached to that 70. But if we know the whole thing's 90 and this piece is 70, what does that piece have to be? Hopefully you're saying 20. Okay. All right, I'd like you to take a second to do problems 5, 6, 7, and 8 with your group. 5, 6, 7, and 8 with your group. Okay, let's see how you did. So, we want to find the measure of angle BCD. BCD is my central angle. Remember, your central angle and your circumscribed angle are supplementary. So, 180 minus that 32 gives you 148 degrees for your central angle. I also want to know the measure of angle CDA. So CDA is your tangent piece, so you should have gotten 90 degrees. Now I want to know the measure of angle BED. BED, what type of angle is that? Hopefully you're saying hopefully you're saying inscribed. This is an inscribed angle because the vertex is on the circle. Now, this one was probably a tricky one if you don't remember your rules. So, we know that our central angle is 148 degrees. The angle, or the arc, that central angle creates is this arc here. Central angles and the arc that they create are congruent to each other, which means this arc is 148. We also know that inscribed angles and the arc that they create have a formula that we use. The arc, or the angle, is half of the arc. So if I know the arc is 148, the angle we would divide by 2 and get 74. So that uses your definitions from the last week. And then our last one, where am I at? DBA. You're going to do the same way we did up here with our isosceles triangle. And you should have gotten 74. So again, you have an isosceles triangle that has 32 up top. Both of those angles are going to be equal to each other because this is the angle that you are determining right here, this little piece. Set up your equation and solve, and you end up with 74. Okay. All right, let's do number 9. So number 9, we have a central angle and a circumscribed angle. Again, we know those are supplementary. So let's add those together. 2x minus 7 plus x plus 1 equals 180. If I combine like terms, I get 3x minus 6 equals 180. 3x equals 186. And when I divide by 3, I get x equals 62. Okay, now that I know what x is, I can fill in all this other information. So the measure of NQM. So NQM is my circumscribed angle. So 62 plus 1 is 63. PNQ, this is your tangent piece. So that's automatically 90 degrees. And then NPM is your central angle. So 2 times 62 minus 7 gives you 117. I would like you to take a second and complete number 10 with your group or on your own. All right, now that you've had a second to do that, again, you have a central angle and a circumscribed angle, and they are supplementary. So 6x minus 10 plus 2x minus 2 equals 180. I'm going to combine like terms, so 8x minus 12 equals 180. If I add 12 to both sides, I get 8x equals 192. And 192 divided by 8 should have given you x equals 24. If you plug everything back in, you end up with 46. This is 90, it's your tangent, and then 134. Okay. These final two problems you can do. They are decimals and fractions. I want you to attempt them right now. Remember, they are tangent pieces so that they are congruent to each other. Okay, they are tangent, so they are congruent to each other. So take a second with your group and attempt these two, even with the decimals and fractions. Okay, now that you've had a second to do that, we are going to set these equal to each other. So I should have 3x minus 1.2 equals 2x plus 1.8. I am going to subtract 2x from both sides, so x minus 1.2 equals 1.8. If you add 1.2, you need to line up the decimals. You also have a calculator. You end up with x equals 3. We want to know what EF is, so we're going to plug it back in here. So 3 times 3 is 9, minus 1.2 gives you a total of 7.8. That one should not have been challenging. Number 12, I expect a little bit more of a challenge. So let's see. Not too bad, though. Actually, I lied. Number 12, we do not know how to solve yet because we have not learned how to factor. So you can cross out number 12. We won't have one like that. All right, guys, I know I went fast. If you have any questions, I know Mr. Boykins can answer them for you. And I will see you tomorrow. Bye.